All right, hey honors chemistry. So I'm going to be talking about worksheet number 3 in this video. And this video is going to be some notes that I hope you copy down, and then hopefully it helps give you information to do 2 questions on your own. I would like you to at least copy questions 1 and 2 down for me to check on Monday that you copied and took some notes, and then at least attempt in questions 3 and 4 on your own for homework. If you're in 4th hour, we did a lot of this together, so I'm hoping that you're looking at questions 4, 5, and 6 on your own for homework. Okay, so this is called adjusting to reality limiting reactant. And from time to time, I'm going to bring up the word limiting reactant, and I'm going to have this definition here. Eventually, I would like you to copy down these notes. But the limiting reactant we're going to see is a reactant that gets completely used up, is not in excess, so it is not going to be stuff that has left over, and it will produce the least moles of product. And in general, for us, whatever my limiting reactant is, I'm going to use my moles of my limiting reactant to determine the moles of my product using the mole ratio. Okay, so in general, this is what's going to be happening in this worksheet. So let's start with question 1. It says, write the balance equation for the reaction between hydrogen and oxygen. Well, it forms water, so H2 plus O2, those are going to react to form H2O. And if I want to balance this, it'll be 2H2 plus O2 yields 2H2O. All right, and again, the way that we read this is for every 2 moles of H2, I need 1 mole of O2 to make 2 moles of H2O completely. Well, I could also read this as for every 2 molecules of H2, I need 1 molecule of O2 to make 2 H2O. Okay? It says now that suppose we have 4 molecules of hydrogen gas and 4 molecules of oxygen gas react to form water. Make a drawing that represents the reaction container before and after. Now, I already began doing the before box. I have my 4 molecules of hydrogen. And remember, molecules means more than one atom. So I have 4 molecules of hydrogen, 4 molecules of oxygen. And in order for me to make water, it looks like 1 oxygen atom and 2 hydrogen atoms. So I could begin trying to take this away. So I could start taking from my before reactants and start making my products. So I'll do one at a time. 1 H, 2 O's, and now I got water. I could do it again. 1 O, 2 H, and now I have water. I think I might have accidentally said it wrong before, right? So these are O's, these are H's. For every 1 O, 2 H, 1 O, 2 H, 1 O, 2H. 1O, 2H. All right, and now I have run out of hydrogens. I'm going to make a note of that. Ran out of H2 first. So it's all used up. And I have this O2, I have 2 O2 left over. Okay, so how many molecules of water can be produced? Well, according to what I just did, 1, 2, 3, 4 molecules of H2O can be produced. Which reactant is in excess? It looks like my O2 is in excess. It's left over. I know it's in excess because it's left over. I don't have any more hydrogens to react with it. I need more hydrogens. How many molecules of excess reactant are there? 2 molecules of O2 is what's left over. Now we're going to talk about the excess method. Right now, going back to our definition of limiting reactant, it is not in excess. So whatever reactant is in excess is not our limiting reactant. So right now, using just that definition, my O2 is not my limiting reactant. It must be my H2. So let's use this excess method. Let's write the balanced chemical equation again. 2H2 plus O2 yields 2H2O. I have my before, change, and after. Okay? Now, before, I have two quantities. 4 molecules of H2, and I have 4 molecules of O2. And before the reaction, I have no H2O. Okay? I'm supposed to put moles in my BCA table. We could use molecules. Okay? They could represent moles. Alright? Now, notice, this is the first time ever that we have 2 amounts of reactants in my BCA table. If I have 2 amounts of reactants in a BCA table, that is going to make this a limiting reactant type problem. So I already said in doing the problem up here that I'm using up all of my H2. In drawing the particle diagrams, I've used up all my H2. So I know I'm using up all of my H2. How much of my O2 do I need? Well, for every 2 H2s, I need 1 O2 or half as much. For every 4 H2, I'm going to need 2 O2s, which is half as much. And I'm going to have 2 molecules of O2 left over. And I have no H2 left over. And if I do this math correctly, if I use up all 4 H2s, I should make, it's a 2 to 2 ratio, I should make 4 molecules of H2O. 4 molecules. So according to this table that I just made, how many molecules of water can be produced? Like we just said, 4 molecules. Which reactant is in excess? Well, according to BCA, BCA says O2, and it's 2 molecules of O2 that's left over. Now, based on your 2 methods of analysis above, what determines how much product can be made from a particular reaction mixture? Well, whichever reactant is completely used up, this is known as my limiting reactant. Whichever reactant is completely used up, I have no more of it, it drives my reaction. That's going to be the mole ratio to determine how many products I have. If I use my moles of O2, or my molecules of O2, if I have 4 molecules of O2, how many H2Os should I make? Well, for every 1 molecule of O2, I should make twice as many, or 2 times the H2O. With 4 molecules of O2, I should make 8 molecules of H2O, but I've only made 4. So something else limited how much product I could make. Okay? So this is just the beginning. So back to our definition here and which one that we use. The limiting reactant gets completely used up. We did that. That was kind of like our H2. It got completely used up. I had none left. It is not in excess. Okay, so the O2 was the element that was in excess. That is not the limiting reactant. And then finally, and we're going to see this in the next question, it produces the least moles of product. I want to use my moles of my limiting reactant to determine the moles of the product. I'm going to say this a lot. So I'm using my moles or my molecules of limiting reactant to determine the molecules of product. Okay? So now let's move on to the next question. The next question, I already kind of have it started for us. Next question says, write the equation for the formation of ammonia, and ammonia is NH3. Remember, the ammonium ion is NH4 plus 1. That's the ammonium ion. Ammonia is just NH3. Write the equation for the formation or synthesis of ammonia from nitrogen gas and hydrogen gas. So nitrogen gas, N2 plus A2, H2 equals NH3. If I want to balance this correctly, I should have 3 H2s, 2 NH3s, 1 N2. Okay? Now, Given 6 molecules of nitrogen and 12 molecules of hydrogen, make a drawing that represents the reaction container before and after the reaction. So I've already got my before going on. I have my 1, 2, 3, 4, 5, 6 molecules of N2 and my 2, 4, 6, 8, 10, 12 molecules of H2. Now I have to combine them. For every 1 N2, I will need 3 H2s, and that will give me 2 NH3s. Let me use my balanced chemical equation with these ratios to make my amounts of product. So I need 1 N2 and 3 H2s. 1 N2 and 3 H2s, that's going to make 2 NH3s. So NH3 and H3, right? So for every 1 N2 and 3 H2s, I could make 2 NH3s. Let me do that again. For every 1 N2 and 3 H2s, I can make another 2 NH3s according to my balanced chemical equation. That's what this balanced chemical equation means. For every 1 N2 and 3 H2s, I could make 2 NH3s. Let me see if I could do this again. For every 1 N2, and let me see if I could grab this down to 3 H2, I will make another 2 NH3s. Okay, and then one more time. For every 1 N2 and 3 H2s, I could make another 2 NH3s. 1, 2, 3. 1, 2, 3. Okay, and now I have 2 N2 left over. Okay, how many molecules of ammonia can be made? If ammonia looks like this, I made 1, 2, 3, 4, 5, 6, 7, 8 molecules. Which reactant is in excess? It looks like my N2 is in excess. It is left over, not used up. How many molecules of excess reactant are there? It looks like there are 2 molecules of N2. Okay, again, definition here. The limiting reactant gets completely used up. So it's looking like in this case all of my hydrogen are used up. So my hydrogen, again, is my limiting reactant, is not in excess. Hydrogen is not in excess in this problem. It looks like nitrogen is in excess. N2 is in excess. So it's not the limiting reagent or reactant, LR. And it's going to produce the least moles of product. So I'm going to prove to you that this 8 moles is my least moles of product. We're going to do this BCA table a little bit differently. We're going to look at moles of product. So I'm going to write my balanced chemical equation. And I'm going to make this BCA table a little bit different now. Kind of have this split. Okay, I made a bigger line here. And I'm going to write from N2 from H2. All right, I'm going to do 2 different mole ratios and see whichever one gives me my lowest moles of product. Again, going back to my definition, it produces the least moles of product. My limiting reactant is a reactant that limits how much product can be made. Okay, so for my N2, I was given 6 moles. For H2, I was given 12 moles. Okay, now I'm not going to do my change yet. I don't know which one is my limiting reactant just from a BCA table. I'm going to prove that my limiting reactant is H2. So let me see, using Mouldable Ratios, for every 6 moles of N2, how many moles of NH3 can be made? Well, if for every 1 mole of N2, I make 2 moles of NH3, for every 6 moles of N2, I should make 12 moles of NH3. And then if I have 12 moles of H2, how many moles of NH3 can I make? This is a 3-to-2 ratio. I want to go over and back to our dimensional analysis. Okay? So if I have 12 moles of H2, I want to use my mole ratio here, which is 2 to 3. For my balanced chemical equation, I always put the moles of H2 on the bottom, and that's 3, and the moles of NH3, which is what I want, on top. 12 times 2 divided by 3 is 8 moles. And on the bottom is where I did the 12 moles for NH3. And it's looking like if I'm comparing my H2 moles and my N2 moles, my lowest moles between 12 and 8 is 8 moles. So it looks like from the H2, if I use my 2 to 3 ratio, I get 8 moles of NH3. So let me make sure I'm doing, this is just work. I didn't do any answers yet. This is not the answer yet. So from my mole-to-mole ratio of my reactant N2 to my product NH3, it's 1 to 2. So if I have 6 moles of N2 and I use it up completely, I will make 12 moles of NH3. But if I have 12 moles of H2 and my mole-to-mole ratio is 3 to 2, I actually only make 8 moles of NH3. And so what you're going to do here for limiting reactant is choose the reactant that produces the least moles of product. It's going to limit how much product you can make. Now remember my analogy with the sandwiches, okay? Mr. Tonelli likes his bologna and cheese sandwiches. If my sandwich requires 2 slices of bread, a slice of bologna, and a slice of cheese, I could make 1 sandwich. If I have 4 slices of bread, 2 slices of bologna, and 2 slices of cheese, I could make 2 sandwiches. But what if I had 4 slices of bologna and 4 slices of cheese, but only 2 slices of bread? How many complete sandwiches can I make? Well, with that analogy, I can only make 1 complete sandwiches because I have only 2 slices of bread, and that's how much I need for 1 sandwich. I'll have excess bologna and cheese, and it looks like my slice of bread in that example is my limiting reactant. And it limits how much sandwiches I could make, kind of like limiting how much product I could make. So use that analogy to answer this question, right? I'm going to say this is my least moles of product. This is how much will be made. 8 moles of NH3 will be made. So if I have 8 moles of NH3, that came from the H2. I'm using up all of my H2 minus my 12 moles. My H2 is my limiting reactant. H2 is the limiting reactant. Because my H2 gave me my lowest moles of product. Again, my limiting reactant produces the least moles of product. And it's the one that gets completely used up. So if I use 12 moles of H2 with the 1 to 3 ratio, I should use 1/3 the amount of N2. I should only use 4 moles of N2, which would leave me with 2 moles of N2 left over. And guess what? That is what I had up here. Here are the 2 moles of N2 that are left over in excess. Okay? How many molecules of ammonia can be produced? We said 8 moles or molecules. Which reactant is in excess? We determined it's N2. It does not get used up. How many molecules of excess reactant are there? It looks like 2 molecules of N2. So the question becomes then, describe what you must look for in a particular reactant mixture to decide which reactant will be in excess. Well, it is not used up completely, and it may produce more product than expected. It looks like my N2 would produce 12 moles of product. But now we know that I perform and produce my lowest moles of product, which is my H2. All right, and these numbers match my BCA table up there. Okay, so now what I would like you to try and do is try and apply either one of these two methods to questions 3 and 4. And I'll get you started on 3. The balanced chemical equation is aluminum plus iodine, or iodide, gives me Ali3. And if I want to balance this, it becomes 3I, 2, 2. Okay? So, you could look for, in constructing this BCA table, how many moles of Al3 could come from Al, and how many moles of Al3 could come from I2. Look for lowest moles of product. Okay, so I give you the moles of both aluminum and iodine. If I give you the amount of my reactants, both of them, this is a limiting reactant problem. I give you the amounts of each reactant, it's limiting reactant. So you're going to figure out whether my aluminum limits the amount of moles of Ali3 or my iodine limits my moles of Ali3. Okay? So, what I would like you to try and do is work on question 3 and 4, and that is all you have to do for this weekend. If you are still having troubles or concerns, or you did not understand or have some clarifying questions on the work that I provided on the previous page, let me know. Please send me a message in the Remind or message on the Google Classroom. I may provide another video for another example to do this over the weekend, but I would like you to try and do questions 3 and 4. If you are in fourth hour, you are moving on to questions 5 and 6. We started the 3, you should do 4, but then you're going to end with 5 and 6. And be careful, question 5 and 6, and so is 4, is giving you grams. So what do I have to convert those grams to? Convert grams to moles. Okay? All right. Hopefully this will be a very useful video for you. When all else fails, you could use particle diagrams like we have before. You could use particle diagrams to figure out the limiting reactant. Just know, if it is in excess, it is not limiting. If it gets completely used up, it is limiting. Alrighty, good luck, Honors Chemistry.